Okay, we have quadratics, complete the square, factoring by quadratics, regular quadratic formula, solving general equations, which is like the square root, squares, that kind of thing, and then being able to tell me how many real solutions we have. Discriminant, b squared minus 4ac. Okay. We have word problems, mixture. They can consist of the three different types: metal, chemicals, and fluid, fruit juice. 17 would be inequalities, or I'm sorry, 1.7 is inequalities. We have simple inequalities that you just have to graph, quadratic inequalities that you have to factor and then solve, and then absolute value inequalities, which require that you change to the equivalencies. We have circle equations, being able to tell me it through a point by using it standard to complete the square. And then circle equations through a point, I think I already went over that. 1.10, which is parallel and perpendicular, and then lines through a point. So we've got to be able to tell the difference between all those. The first problem we're going to go ahead and do, okay, this goes back to how do you identify them? How do you identify the different types? If you want to take a picture of it, I'm going to try to go through as many problems as I possibly can. We have about 23 or no, 27, so maybe 30 minutes. How many kilobytes or kilograms, sorry, of metal containing 10% must be combined with 4 kilograms of metal containing 40% gold to form an alloy of 18% gold? So when I'm looking at these, I'm thinking about being able to write them out. The first thing that screams out in my mind, and I'm going to kind of rewrite this. Solution 1, solution 2, and our final. I always know that this is going to be my x variable up in the front. And I just want to be able to fill in the information. If we know our first solution, how many kilograms of a 10%? So we don't know the first one, so 10%, that's too dark, too light. Sorry, again, my tablet dived out on me. Must be combined with a 40% at 4 kilograms. To create a final solution of 18% gold. So this is where it comes into play. One thing that you want to be able to see here is it's not giving you that much information on any of the final solution. Since I know I have solution 1 and solution 2 all set up already, if we're given 2 solutions and nothing about the final, I know the final product has to be adding. That's how we want to be able to identify it. Okay, so this is adding. If we look at the other one, I'm hoping I found this one. Again, doing the same thing. We have solution 1, solution 2, and our final. Now it tells us in the beginning that Ron wants to make a 15 ounce at 22. So it gives us the final. It automatically gives us a final. By mixing together a 24% solution, what do we always know that the first solution happens to be? X. And we're going to combine it with an 18% solution. How much should we use of each? In this case, we are given the solution for number 1 and a final solution. So this is set up differently than the other one. Since they have one solution and a final, how do we fix our equation? Subtraction. Does that kind of help you guys understand that? I can give you both, depending on how you want to set it up. Okay, I'm not going to solve those out because I think from here you guys should be able to do that. Okay, You definitely want to be able to use the calculators and solve those out correctly. Okay, this is subtraction. So I put subtraction. This will be posted as well today, so FYI, it will be posted. For whatever we get done in here, I'll try to do both of them. Okay, I'll try to do everything, but there's a lot on here. I want to make sure you guys are prepared. Okay, here we go. Next type of problems that you guys can see are the following. So if you want to copy those down, you're more than welcome to. These are like the basic forms of them. Simplify the expressions. So this comes from, I believe, 1.5. The other one was 1.6. The previous one was 1.6. I'm just going to kind of get started on these. I'll give you guys, if you need the answers, yeah, see me. I would be here after school, but I got a football game, so I won't even be here. Driving to Bishop Amont. So excited to leave here at 1:30 to start a game at 4. So excited. So excited. I'm simplifying the expression because I know it happens to be square root. The best thing I want to be able to do is write out perfect squares. 1 is definitely 1, but that's not going to help us. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. Okay? You can do this indefinitely until you have a substantial amount. We want to be able to write this as a product of two radicals, specifically one being a perfect root. 75 can be written as what? 25 and 3. What about 48? Try to find your largest multiple using them. 16 and 3. In our first one, we can reduce down to 5 root 3. The second one can be reduced down to 4 radical 3. Once we have that, we can pretty much just add up the integer terms, which is going to be 9 root 3. I think it would be smart to practice this today. Just say. Okay. So you definitely want to be able to do those. The bottom one, which is simplifying with radical expressions, we want to be able to look at this type of problem and solve it out by first getting rid of the negative values. So in this case, both of my a's are going to switch because they're negative. So whatever is on top is going to go on the bottom on top. So I'm going to get a to the 5th on top. And I'm going to get a to the 3rd on bottom. Just because I want to be able to switch those up. My b to the 4th is going to remain the same. B to the 5th is going to remain the same. Okay. I'll write out that 5 a little bit better. From here, we're going to be able to reduce down. Reducing this down, you can just pretty much subtract them. So I'm going to take 5 away from 3. This leaves me 2 on top. So I'm going to get a squared on top. I'm going to take 4 away from 5, which is going to leave me 1 on the bottom. So I'm just going to get b to the 1st power, a squared over b. You do not need to give me the negative values for them, and I'll probably tell you them tomorrow. Do not give me negative values. Okay. So that's that one. We want to be able to factor the expression completely. Being able to factor with the value that a is equal to 1 gives you a simple snowflake of AC and B. That's how we want the factoring snowflake to look like. Okay? If we do this correctly, A times C is going to be 15. B is just going to be negative 8. What multiplies to give you 15 but adds up to give you negative 8? Negative 5 and negative 3. These are going to become your factored terms. X minus 5, X minus 3. Does it ask us to solve? No. We're just factoring. Okay, there's no equals 0. There's no value we need to set this equal to, so we just leave it. The bottom one is when a is not equal to 1, we have to use the advanced snowflake method. In this case, we're going to get AC on top, AX on the top of here, whatever that AX happens to be, and then we're still going to get the B on the bottom. So we want to be able to see what that's going to provide. It's my advanced snowflake. 2x, because my A is 2. The top two values here is going to be A times C, which is 6. And the bottom one's going to be 5. What multiplies to give you 6 but adds up to give you 5? 3 and 2. This is our first product, our first factor, 2x plus 3. But we also can see here that we can actually reduce this right side down. What can we reduce it down by? It's just going to be x and 1, right? We can reduce it down by 2, so our final factor will be x plus 1. It's a great viewing if you need to solve for factors. Set each part equal to 0, but we don't need to do that because we're not solving for anything. Is this kind of going good, just doing this real quick to kind of refresh your guys' memory? Hoping so. Okay. Factor the expression completely. In this case, this is factoring by grouping. Whenever we have 4 parts to it, we want to be able to split it up. I'm going to split it up down the center here. I'm going to pull up my GCFs between both sides. My GCF on the left side is going to be y squared. This is going to leave me y minus 3. My GCF to the right hand side is my negative 4. Y plus 3. The factored term that's already there is going to be your first equation. Oh, minus. Thank you. Going fast. Our first shared factor is going to be the first value here, y minus 3. That's something we don't need to change up. If you get this, you already get some credit from there. The remaining portion to this, what I saw a lot of people mess up, and it's important that you guys realize, is the second portion. That y squared, can that be factored? Y squared minus 4. Yes. Yes, it can. Okay. As a term of perfect or difference of squares, y minus 2 to y plus 2. Without having this, you don't get full credit. Okay. If it's not factored, we would leave it. If it was y squared plus 7, we wouldn't be able to factor it. Okay. We want to be able to reduce this down the best we can. So we've got to be able to do this full length in order to provide me all the points for this. How much more time do we got? What time do we do? Okay. The bottom portion of this, we're going to go ahead and reduce down or simplify out this fraction. This is one of the other different types that you guys are going to see tomorrow. It's important that we realize that the bottom two are going to be the common denominator. We're subtracting them, so what we want to be able to see is create the common denominator between both of them. Easiest way to do that is just to multiply them both together or be able to see what the other part's missing. In this case, it's going to be x plus 1, x plus 2. My left-hand side is missing x plus 2. The right-hand side is missing x plus 1. So this is just going to give me x plus 2. I'm going to keep that minus. We want to be able to simplify this out the best way we can. We're going to go and reduce out my fraction. This is going to give me negative x, a negative 1. So x minus x is going to simply go away. And then plus 2 minus 1 is going to give me the other part. We're going to get just 1 over done. I know it says factor expressions completely, but this is more so simplifying fractional polynomials or fractional linear equations. Whatever works. Good stuff. Here we go. Again, you can find this all online. This stems up from, I believe, 1.7, because we already did 1.6. So 1.5, we did 1.6 with the mixture. This is 1.7. 1.7 is dealing with a bunch of quadratics, the absolute value, quadratic absolute value, all that kind of stuff. It's hard to believe 2 weeks ago it was like blazing hot already by this time. It felt nice. I was like, oh, it's cold. Oh, I'm so excited. I like being lazy. I do. First one here, we want to be able to factor out completely by completing the square. So find a number that multiplies to 2 but adds up to -4. You can't find one. If you didn't know how to complete the square, what's another method you could use? Quadratic. Okay, quadratic. I do want you to simplify the best way you can, but I'm not going to be specific. I'm not going to be specific. Unless it asks you, use completing the square. Okay? If it doesn't ask you and just asks you to solve, use whatever method you want. In this case, I'm going to go ahead and subtract out 2 from both sides. I'm going to leave a space here to get that -2. To find the CTS, or the squared term, we're going to take our b divided by 2 and square it. -4 divided by 2 is -2. -2 squared is just 4. Whatever we do to one side, we got to do to both. Our new factored term here, our new factored term is going to give us x minus 2 squared is equal to 2. We're not done yet. Just by completing the square doesn't help us with really solving. We got to be able to do the extra steps. The extra steps would be solving it. My first step would be to do what? Square root. I heard someone say it already. Whenever I take the square root, what happens? Plus or minus. Without that plus or minus, portions of it wrong. You got to be able to have that for tomorrow. And then all we want to do is just add 2 to both sides and we're done. I'm okay with leaving it like that. Okay? I'm okay with leaving it like that. I did the problems yesterday, and I actually had to change this because it was simplified. And I don't want you guys to have to simplify it. I just want you guys to do it. Okay, so this is good enough. The square root of 2 is like 1 point something, 1.3, 1.4. Oh, a little bit less than that, maybe less than 5. 1.5. The other one is slightly different as well. This might be something really good to go over later as well. Just throwing it out there. Not saying, but I'm just throwing it out there. Might be a good problem to go over. Not saying it, but your choice. This is completing the square by the advanced way, right? This is just like the team test one. I'm going to take out, just as the first one did, but I'm going to bring over the -3. From here, I'm going to pull out the GCF. Still leaving a blank there. -3. Take the inside value, divided by 2, and square it. It's not going to be pretty on this one. It's okay. I'm just kidding. It'd be what? -3x. Take 3 divided by 2 and square it. 1.5, 1.5 squared. Oh, that doesn't work out good at all, does it? Let's do this. Change up the problem. Change up the problem to 8. Change this 6x to 8. That will fix us up. make this more successful. Is that better? It'll help it out. I don't know if it gives us a better term, but it'll help us out. Take that divided by 2 and square it. Negative 4 divided by 2 is negative 2. Negative 2 squared is 4. But how much are we actually adding? Negative 8. So we're going to add negative 8 here. We're going to go ahead and complete the square. So minus 2 is still going to be up in front. X minus 2 squared. Negative 3 minus 8 is what? Is it 12? No, 11. Just kidding. From here, we're going to divide everything by negative 2. 11 over 2. Taking the square root. Oh, sorry, you guys, from the guys back there. I hate writing low. And then our final part, which is just adding 2 to both sides. Might be a really good problem to go over. Might be. Maybe. Maybe. Yes? In this case, the completing the square term is what we had to do, right? What is this value? Negative 4. Take it, divided by 2 and square it. It gives me what? 4. But because I have this 2 on the outside of here, how much am I really adding into this equation? Negative 8. So because I'm doing it to one side, because I'm technically adding negative 8 here, I also have to add negative 8 here. Does that make sense? If this was 3, how much would I be multiplying by? 12, right? So whatever's in front of it, you got to make sure you're doing it to that term. Okay, that's where I'm getting that negative 8 from. We don't got that much more time, so I'm going to try to punch through these as best I can. Again, you can find these problems online. I'll probably make the second video during lunch and post it for you guys as well. I'll probably get back later on tonight, so I can't do it then. But whatever I can, I'll try to make it so you guys have at least 2 videos. Aguilar 72, YouTube, check it out. It's a plug. Whatever. Okay, here we go. I got to factor this out completely. This is going to go back to 12 up on top, 3x, 7 on the bottom. What multiplies to 12 adds up to 7? 3 and 4. My first term is here. 3x plus 4 is my first factored term. And then we can reduce the right side by 3, which is going to be x plus 1 equal to 0. My first value, if you set it equal to 0, will be negative 4/3. Other one will be negative 1. Done. Dun 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 dun. Using the discriminant. Could someone tell me what the discriminant is? B squared minus 4ac. Beautiful. Okay, we got to be able to say that if it is d is equal to 0, how many solutions do we have? 1. If d is greater than 0, we have 2. If d is less than 0, we have none. So that's what we want to get from that. In this case, I'm just going to take my a, which is 1, b, which is negative 6, c, which is 1. Again, sorry for my bad penmanship. B squared minus 4ac. 36 minus 4 is 32. 32 is positive, so how many solutions? 2 real. Doing the one on the bottom, I want to bring everything over to the left-hand side. b squared minus 4ac positive 36 minus 12 times 9. 36 minus 108. How many solutions do I have? Less than 0? None, or this is actually considered imaginary. Imagination. Good stuff. Let's see how far we can get. Ooh, these are good problems. How much more time do we got? 3 minutes? We try it. We try it. One to the left is finding all real solution of the equation. We got to be able to solve these out correctly and all the way. This comes up to the problems that we did by using simplification for the fractions. It's not always going to look so pretty, but we should be able to do it. Easiest way to do it is to find a common denominator and then cross multiply both fractions and then simplify out by either your quadratic equation or by factoring. We did this yesterday. This was the minus 33x plus 260, right? Comes out to 20 and 13. So got to be able to do those. Creating the common denominator between these two, so I'm going to do this side first. It's going to give me x minus 1. Just for time's sake, I'm going to do this in all one fellow swoop because I know how to do this. I'm going to get x plus 2 on top because this side is missing it, plus x minus 1 on the other side is equal to 5 over 4. Okay, trust me, multiplied just by those parts that I missed. Simplifying this out, we're going to get 2x plus 1 over, I'm going to FOIL this out, x squared minus 2x, let's see, 2x, so I'm just going to write plus x minus 2, is that factored, 5 over 4? Sorry, to save you guys time to actually practice this, I'm going to try to do it. Cross multiply on these both sides right here. We're going to get 8x plus 4 is equal to the other side, which is going to be your 5x squared plus 5x minus 10. Bringing everything over, 5x squared minus 3x minus 14. How do we solve this one out? Quadratic or factoring, you're going to get two values, x is whatever equal to something. Good luck, you all. Have a great day. Be prepared.